In our last video, we learned about solving systems of equations by graphing, and we saw a preview of what happens if you got these two lines that, excuse me, two lines that, let's say, they do have a solution, but when you graph them, they don't quite cross on the graph. As you can see, these two lines are not parallel, but they're going to cross eventually somewhere. And if we keep drawing these lines out, we'll find it. Oh, look, but it's way out there, and we just don't know what number that is. What do you do? Well, I mean, I guess you can expand your graph, you know, and count, or just kind of assume by doing figuring out your slope and all that other stuff. That's one way of doing it. Another way, we're going to learn another way, and this method is called substitution. So let's learn about substitution. Steps to solve systems by substitution. And I actually I really dislike solving equations or systems of equations by graphing. I find that to be the most time-consuming of all of them. Substitution is a method I do like to use. So blank one of the equations for y if necessary. You want to solve one of the equations for y if necessary. And what we mean by that is, like, if you have like 3x plus y equals, I don't know, 10, solve for y means you want y to be by itself. So basically you want to get rid of this 3x by subtracting 3x. Oh, hey, those cancel each other out. Subtract 3x on both sides. You end up with y equals 10 minus 3x, or negative 3x plus 10. So that's what we mean by solving for y. Get it by itself. Blank the value for y in the second equation. You want to substitute. Because when you have a system of equations, you will have at least two equations to choose from or to work with. Substitute. Because you actually need two equations in order to solve a system. Or in order to solve your two variables. Blank the new equation to find x. You want to solve the new equation to find x, and I'll explain what that means. Step number 4, blank the value for x in either of the original equations to find y. In either of the original equations, you want to plug in or substitute. And finally, step 5, blank your answer. They want you to check your answer. Check your answer. Substitute x and y in both the original equations to make sure they make the equations true. That's just a good thing to do to make sure you're doing everything correctly. So we're not going to graph. They don't give us a graph. If we wanted to graph, we could say, oh, this has a slope of 3 over 1 and a y-intercept of 0. And the other one has you got to figure that out. And then graph those lines, or I guess it wouldn't look something like that. But we're not going to do it that way. We're going to solve using substitution. So if we knew that y equals 3x, so y equals 3x, that means y is 3x, right? We're going to replace 3x, we're going to replace y for 3x. That's why they call it substitute. So substitute this y right here for 3x. So you're going to write this second equation, x plus, instead of writing y, you're writing 3x equals negative 32. All right, now that I've done that, I can combine my like terms, can I? X plus 3x, oh, x plus 3x, that's like 1x plus 3x is 4x. And 4x equals, let's do this, 4x equals negative 32. How do I solve for x? Well, divide by 4 on both sides, that cancels. X equals, what is that? Negative 8, I believe. So now I found x. Now that I found x, I can substitute x in this 8 into either the top equation or the bottom equation to find the value of y. So let's substitute it in. I'm going to use green. I'm going to say y equals, let's use this one, y equals 3x, right? Because that sounds like a simpler equation. So we said x is negative 8, so y equals 3 times negative 8. And what is 3 times negative 8? It is negative 24. There we go. Now I have my answer. x equals -8, y equals -24. Now, what they want us to do is check to make sure that's correct in the other one. If I had put -24 in for y and -8 for x, does -8 minus -24 or minus -24 equal -32? It does. So yeah, this solution right here, it works for both of them. If you want to write it as an ordered pair, you would write it, remember x goes first, it'd be -8, comma, -24. That is our solution right there. Or you can also say x is -8, y is -24. That's it. Let's try the next one. So, I've got two equations. Red and blue. Actually, I'm going to mark all my blue equations. Actually, they want us to check in the box below, so I will check in the box below. So y equals, so remember, our solution is -8, -24. Y equals 3x, right? Y is -24 equals 3 times -8. That is -24. That's true. Our next one was x is let's write the equation. X plus y equals -32. Let's see, x is -8, y is -24. Does that equal -32? It does. Both correct. All right, so for this one, we know y is 9x minus 2, right? Y is 9x minus 2. So we can replace 9x minus 2 for that, right there. Or you could do it the other way. You know that y equals 3x plus 10. So you can say, oh, well, if y equals 3x plus 10, then I could replace that y with 3x plus 10. So I'm actually going to do the first way. Does it matter which way you do it? No, not really, especially in this one where they're both written in slope-intercept form, so it's super simple. So I'm going to replace this y right here with 9x minus 2. 9x minus 2 equals, and then bring this part of the equation down, 3x plus 10. All right, how do I solve this? Well, get all my x's on one side. So I'm going to get rid of that x. That equals 6x. And then I need to, now that I've determined that my x's are going to be on the left side, I need to get rid of everything else here. And what else do I have here? Well, this constant right here, this -2, so get rid of it, add 2 to both sides. And that gets me 12. 6x equals 12, divide by 6. X equals 2. So now I know what x is. Let's solve for y. Which equation should I use, the top one or the bottom one? Does it really matter? No, let's go ahead and use the bottom one. So y equals 3. Instead of x, I'm going to use 3 times 2 plus 10. That equals 6 plus 10, which is 16. So y equals 16. Let's see if that, let's go ahead and write it as an ordered pair. That's 2 and 16. Is what we're saying it is. So let's try that. 2, 16. First equation. Y equals 9x minus 2. Let's do y is 16. 16 equals 9 times 2 minus 2. That is 18 minus 2, which is 16. Does 16 equal 16? It does. Let's try equation number 2. Y equals 3x plus 10. Y we said is 16. 3 times 2 plus 10. 3 times 2 is 6. 6 plus 10 is 16. Does 16 equal 16? It does. Therefore, this solution is correct. Ta-da! 2 and 16. Let's try number 3. Oh, I didn't mark this as red. Let's do it. All right. Y is already isolated right here, so it's actually easier to stick this y down there. So let's take that y and put it in there. Okay, so I'm going to use that blue equation, 5x plus 6y. Now y is going to be replaced by this right here, right? So we need to put in parentheses because it's being multiplied by 6, and it's negative x plus 4. And that's going to equal 13, right? So we said 5x right there plus 6y, and remember this y is getting substituted by this, equals 13. There it is. Now let's simplify this. How do I do that? Well, I can't combine negative x and positive 4. They're not like terms. So I am going to distribute. That is negative 6x, because 6 times negative x is negative 6x, and 6 times positive 4 is 24. Bring down the 5x, bring down the equal sign, bring down the 32. We need to solve this equation. We do that starting by, let's see if we can simplify this side. Are there any like terms combined? There are. I can combine this 5x and this negative 6x, and that equals a negative x, or negative 1x, plus 24 equals 13. Okay, what next? Well, gotta get this by itself, so subtract 24 from both sides. 24 and 13 are like terms, so I am going to combine them. What is 13 minus 24? Or 24 minus 13? Our answer is going to be negative. 24 minus 13, was it 11, I think? And then negative, the only thing left over on this side is negative 1x. So negative x equals negative 11. Different ways you can do this. Divide by negative 1, multiply by negative, it doesn't really matter. You end up with x equals positive 11. All right, so now that we know x equals 11, we are going to substitute that back into one of the equations. Which one should I do? I'm going to do the top one. That seems easier because it's just like negative 11 plus 4. So let's do that one. Y equals negative x plus 4. And I am replacing x, negative 11 plus 4. What is negative 11 plus 4? It is negative 7, I believe. Y equals negative 7. So let's see if that is, well, the ordered pair would be x is 11, y is negative 7. Let's see if that is true. Let's do the red equation. Y equals negative x plus 4. The blue equation, 5x plus 6y equals 13. All right, we know that, or we said that x is 11, y is negative 7. Let's see if that's true. Y is negative 7. Actually, let's use red. Negative 7 equals negative 11 plus 4. Let's see. Negative 11 plus 4 is negative 7. Yeah, that's true. Let's do the blue one. 5x, x is negative 7, plus 6y, that's 11, equals 13. Let's simplify this. That's negative 35 plus 66 equals 13. Is that true? Did I do something wrong? I feel like I did. Because doesn't 66 minus 35 equal 13? I don't think it does. I must have done something wrong. That's, that just, let's try that again. 66 minus 35. That's 31. I did something wrong here. What did I do wrong? Let's see. Y equals, if x is 11, 11. So, I must have done something wrong when solving for x is my guess. So, let's try this. 5. That's why it's so important to check your answers. So 5x plus 6 negative x plus 4 equals 13. All right, 5x minus plus minus 6x equals 20. That is positive 24. True. Let's see, maybe 5x minus 6x is negative 1x. Subtract 24 from both sides. I end up with negative 11 divide. I get positive 11. Oh, you know what I saw? Oh, you know what I did? I didn't correctly. Whew, that was a waste of time. 5 times 11. My goodness. 6 times negative 7. What a waste of time. I'm sorry. That is 55. Plus 6 times negative 7 is not going to be a plus. That's going to be a negative. 30, 36, 42 equals 13. Does 55 minus 42 equal 13? It does. That checks out. Holy cow. Yeah, sorry about that. That is the correct answer. That's what I get for rushing in my head. Where do you feel like it's easiest to make a mistake when solving system by substitution? For me, it's with all the signs. When you do the distribution, and you need to make sure you get the signs, but shoot, even when I checked answers, replacing the right variable with the right number can be tricky. So, or you can make mistakes on that. So let's go ahead and try these next couple of questions. Number 24, we have, let's highlight these. Oh, in this case, we know y equals 3x minus 5, so I'm definitely taking this y and replacing it with that. So I'm going to do the red equation. Negative 3x plus 4y, not y, but whatever the substitute for y is, which is 3x minus 5, equals 7. Let's do some distribution. positive 4 times 3 is 12x. Positive 4 times negative 5 is negative 20. Bring down everything else. Well, this is a positive 12x. That's a negative 3x. This is an equal sign. That's a 7. Combine your like terms. That is negative 3x, positive 12x. That is 9x minus 20. That's going to equal 7. Get x by itself. Add 20 to both sides. They are like terms, so should work. That equals 27. That cancels. 9x equals 27. Divide by 9. That cancels. X equals 3. Let's try looking for y now. I'm going to plug that into this equation. Y equals 3x minus 5. So instead of x, I'm replacing 3 with 3, which is the answer over here. So y equals 3 times 3 minus 5. That is y equals 9 minus 5. That is 4. Y equals 4. Let's make sure that that is the correct answer. The ordered pair is 3, 4. I know for sure that's going to be correct for this one because that's the one I actually solved for. I need to check it really for the other equation, the one I didn't check. So I'm going to just check 3x plus 4y equals 7. So x is 3, y is 4. Let's be clear on that. 3 times 3 plus 4 times 4 equals 7. That's negative 9. That is 16. Does 16 minus 9 equals 7? It does. That checks out. We know that this will work for the other one, for the blue equation, because I solved for that. So let's go ahead and try number 5. It looks like I do not have either of these in y equals mx plus b form. So I should probably, what I probably should do is I should probably fix one of these, solve for y. And it seems like, let's see, the first one, negative 2x plus y equals negative 3. And the second one, negative 6x plus 4y equals 4. Seems like the first one is going to be the easiest one to do because I just need to move the 2x over, or negative 2x over. So for that red equation, all I need to do is like add 2x to both sides, right? Because that'll cancel. Add 2x to the other side. And then what do I get? Well, let's go ahead and write it on the side. This side, negative 2x plus y equals negative 3. What I'm going to do is add 2x to both sides. That'll cancel. Plus 2x. And then I end up with y equals 2x minus 3. So I'm going to rewrite that. Y equals 2x minus 3. All right, now that I know y equals 2x minus 3, I'm going to take this. Oops, I'm going to take that y right here and put it into the blue equation, all right? So you've got negative 6x plus 4y. Remember, y is 2x minus 3 equals 4. Let's do distribution. Positive 4 times 2x is 8x, and positive 4 times negative 3 is going to be a negative, and it's going to be negative 12. That's a plus, remember, and this is minus 6x. Equal sign 4, combine your like terms, negative 6x, positive 8x, that is 2x, minus 12 equals 4. Get x by itself, solve for x, plus 12 to both sides. I end up with 16, right? 2x equals 16, divide by 2, x equals 8. All right, now that I know x equals 8, I can plug it into the top equation, the red one, or the bottom one, the blue one. Now, it doesn't matter which one, whether I do it in the one I made or the original one. No, technically, if I did this correct, I could plug it into this, but if I messed up, it might be worthwhile to check one of their equations. So I'm actually going to do that instead, even though I can actually use my red equation up here because it's easier. But let's go ahead and just use theirs. Let's go ahead and do the blue one, I suppose. So, or the red one. Actually, you know what? I'm confident. I know I did it right. Let's just use that one. Oops, not orange, red. So our original equation is y equals 2x minus 3. X is 8, we said, minus 3. That is 16 minus 3. So y equals 13. So now we have an x and a y. X is 8, y is 13. Let's see if we did this correctly. You know what? I forgot to highlight my answers in the last one. Here it is, and there it is. Womp. There we go. All right, let's check our answers. We said 8 and 13, and remember, this is x and this is y. We've already checked our red equation. Let's try the blue, because that's how we solve for the y. Let's check our blue equation, which is negative 6x plus 4y equals 4. I'm talking about this equation right here. Okay, so we are replacing x with 8. Negative 6 times 8 plus 4. Y is 13 equals 4. That is negative 48 plus this is 40, 44, 48, 52 equals 4. Does negative 48 plus 52 equal 4? Does 52 minus 48 equal 4? Yes, it does. This checks out. Number 6. Let's say we have to fix one or both of the equations. I'm going to fix the red one. So I'm going to do it on the side. But it looks like this is going to be kind of a tricky one. Negative 10x plus 2y equals 4. I am going to add 10x to both sides. That equals 2y equals 10x plus 4. Right? Divide by 2. That cancels. You're left with 10 divided by 2, and then 4 divided by 2. That's 5x plus 2. So my equation, my red equation, is y equals 5x plus 2. Now I can take that, take this y, substitute it into my blue one right there. So let's do it. Negative 9. Whoops. Let's use blue. Negative 9x plus 3y, which is 5x plus 2, equals 18. Let's do some work. Here's the wall. Simplify this. That is 15x, because positive 3 times 5 is 15, or is positive 15x. And positive 3 times positive 2 is positive 6. Bring it down to negative 9x. Okay, simplify this. Negative 9x plus 15x, like terms, that is 6x plus 6, and that's going to equal 18. Subtract 6 from both sides. 18 and 6 are, and minus 6 are like terms. I can combine them. That is 12, and so 6x equals 12. Divide by 6. X equals 2. Whew. X equals 2. All right. Ran out of space there. Let's plug that back in. I'm going to plug it back into the red equation. I'm going to do my red equation. So y equals 5x plus 2, right? I know that x is 2. 5 times 2 plus 2. That is 10 plus 2, which is 12. So y equals 12. So now I have my ordered pair. 2 and 12. Oops, forgot to highlight those answers. All right, let's see. 2 and 12. Remember, 2 is x, 12 is y. I just did the red equation, so I should probably use the blue equation and see if it works there. So negative 9x plus 3y equals 18. Negative 9, x is 2, plus 3 times 12 equals 18. That is negative 18, plus 36 equals 18. Does negative 18 plus 36 equal 18? It does. We are good. We are set. Those are the answers. All right, number 7. The sum of Andy and Brett's ages is 44. Andy's age is 8 more than twice Brett's age. What are the variables in this situation? My goodness. So we have 2 equations. The red one, the sum of Andy and Brett's ages, that is Andy's age plus Brett's age. When I add them up, it equals 44. Andy's age is 8 more than twice Brett's age. So in this equation, we say Andy's age is 8 more than twice Brett's age. So we have Andy's age is, which is equal sign, 8 more than twice Brett's age. So we want to take, you're going to have plus 8. You're going to add 8 to that, and twice his age. So you want to double Brett's age, and you want to add 8 to it. Where are the variables in this equation or in this situation? A is Andy's age, and you've got B equals Brett's age, or is Brett's age. Can you write a system of equations to represent the situation? We just did up there. A plus B equals 44. And then Andy's age is twice Brett's age plus 8. Solve by substitution. This then lists Andy and Brett's age. Okay, let's solve by substitution. I know that A is 2b plus 8, so I just replace that A with this A right here. So replace A with 2b plus 8. So going to my red equation, we've got 2b plus 8. All right, plus b equals 44. Now, I don't need a parentheses right there because I'm not multiplying that with anything, so you can just have 2b plus 8 plus b equals 44. Can I simplify anything on this left side? I can. That's 2b, that's 1b, that is 3b plus 8 equals 44. Subtract 8 from both sides. That cancels. I'm left with 36, I think. Yeah, 36. So 3b, 3 times Brett's age is 36, divide by 3. That cancels. Brett's age is 12. Now I got to find Andy's age. Stick this into one of the equations. Well, let's do this one. That one seems easier. I mean, I guess I could do that one also. Let's just do the second one. So Andy's age is 2 times B plus 8. Let's see. I don't know Andy's age, but Brett's age is 12. So 2 times 12 plus 8. That is 24 plus 8. So 28, 29, 30, 35. That is 32. Andy's age is 32. So that's it. Andy's age. Andy is 32. And Brett, I should have done both in purple. Brett is 12. Let's check to see. Does Andy plus Brett equal 44? So does 12 plus 32 equal 44? Yeah, 30, 40, 44. Does 2b, yep. If I multiply Brett's age by 2 and add 8, does it equal 32? It's 24 plus 8 was 32, yes. So what are the advantages? What advantages are there to solving a system of equations by substitution rather than graphing? We talked about it at the very beginning. If solution is large, or even a fraction, or decimal, then substitution is easier. And that's it. Using substitution. I know that was crazy. That was kind of difficult. There wasn't very much room to do work, but that is that. So go ahead and try some problems on your own. Good luck.